Hello, everybody. Hi. I hope am I audible and visible? And just a minute. Let me just set it up, and we will start. ఒక్క నిమిషం అందరికి. Yes, I hope everything is audible and visible to all of you. Okay, sir. So this session has been actually taken on this pod. It's my first time taking this on a pod, but since it's our last chapter, I think that would be sufficient. ಇದೆ కదా? Yes. Okay, great. So, give me 1 minute. Sorry, I can't access your messages. 1 minute. Yes. Hi, good evening, everybody. Good evening. I should say good afternoon, right? Yes. So, ఈ సెషన్లో yes, 1 minute. Let us make it to teaching mode. And yes, Isha, after a long time. Sir. So without wasting any time, we will directly jump to the session. Andariki, I hope am I audible and am I visible, right? I am audible and visible. Everybody, cheppandi okasari. Sorry. Yes. Done. Completed. Everybody. I can't access your messages. 1 minute. Okay. Good evening, everybody. Good evening. Should be the proper option. So, okay. So the problem that I'm facing right now is I'm unable to access your messages. Okay. So in case I could not see any message, so don't say, sir, you're ignoring a text and something, ra. It's because of this hardware glitch. Ardhamaindi kada? Sir. So now, let us directly start the chapter. Andariki. So the name of the chapter is your magnetic properties. Ide kada? Yes. So you simply say, sir, this is your magnetism. Oh my goodness. Okay. And magnetic properties. Forgive me for this handwriting, okay, everybody. Magnetism and magnetic properties, okay, sir. Actually the pen tab is very small, so it's not habituated. Great. So everyone, this chapter lo we will be talking about the magnetic properties. Not a big chapter, it's a little small chapter, so it might take around 2 hours. So 2 hours lo we will be completing this chapter, everybody. Okay, yes. So what is this? What are the features, sir? Great. So the first topic that we'll be talking about, andariki chuskondi okasari. The name of the topic is your magnetic moment. Okay, magnetic moment. What is happening to the handwriting? Everybody just forgive me for my handwriting and let us see. Chuskondi. Magnetic moment ante enti, sir? It is a property of your magnet. So basically, if you have a bar magnet, all of you, jagrataga vinandi, okay? If at all you have a bar magnet, so a bar magnet lo you have your poles kada? Yes. So a bar magnet lo you have your north pole and you have your south pole. Andariki chuskondi. So talking about the magnetic field lines, everybody, the magnetic field lines start from your north pole and end at your south pole. Ide kada? Yes. So this is something your magnetic field lines look in your bar magnet. Andariki. Similarly, when you talk about inside the magnet, all of you, can anybody tell me what's happening inside the magnet? Me magnet ke inside lo, you'll simply say that your magnetic field lines, they are from your south pole and going towards your north pole. Andariki chuskondi. So you will simply say inside your bar magnet, the field lines are originating from your south pole and going at your north pole. Andariki. So the first thing that we have understood from here is that చెప్పండి. So you will simply say that your magnetic field lines always exist in a closed loop. Ante kada? Yes. So this is your closed loop. Andariki idigo. So these are your magnetic field lines. Ante kada? Yes. We have seen one more phenomena. Andariki. Me magnetism chapter lo ante your magnetic effects of electric current. Our chapter lo we had talked something about your magnetic moment. Gurtunda andariki. So if you have a current carrying loop, idigo andariki jagrataga chuskondi. So if you have a current carrying loop, and this is my metallic loop, I have bent it and there will be a current flowing. Let us say the current is I. Ide kada? Yes. Ippudu let us say the area of this loop is A. So from here we talked about your magnetic moment as M bar is equals to I into A bar. Ardham vachindi? Yes. Similarly, for a magnet, for a bar magnet, what do we call? Your magnetic moment M bar is nothing but small m into the length L bar. Let us see what are the terminologies. So if you have a bar magnet, lo you have your north pole, you have your south pole. What is this small m, sir? This small m is nothing but your magnetic strength. Hey, what is happening to my writing? Your small m is nothing but your magnetic strength. Ide kada? Yes. So small m ante it is your magnetic strength. Now let us talk about the properties. Andariki. For now there are a lot of properties. Kani ippadi kosam I want all of you to remember a single property. What is it? Chuskondi. Your magnetic strength is directly proportional to the area. Ide kada? Yes. Is directly proportional to the area. Am I audible? Am I visible, everybody? You're saying something. Let me see the chat box. Sir. Okay. Sir. So, your magnetic strength is directly proportional to your area. Andariki. Okay. So, if you have a bar magnet, something like this. Idigo. Ide kada? Yes. So the area of the face, ante this is the area. Andariki chuskondi okasari. So this over here is your area. Are you understanding? That means if you double your area, your magnetic field, your magnetic strength actually, it also gets doubled. Ide kada? Yes. So your magnetic strength is directly proportional to area. And ఈ ఫార్ములాలో అంటే యువర్ మ్యాగ్నెటిక్ మూమెంట్ ఫార్ములాలో యువర్ మ్యాగ్నెటిక్ మూమెంట్ is simply equals to your magnetic strength m multiplied by the length అంటే distance రా. This is your north pole, ఇదే మీ south pole. North pole ఉంటే total distance L, లేదా sometimes it is also called as 2L depending upon your situations. Okay, so if you're calling it as 2L, because if you say that distance is 2L, there will be a huge resemblance with your electric dipole. Gurtunda? Magnetic dipole and electric dipole. So there are some common terminologies also we will seeing be over here. Choose. So your magnetic moment m bar is nothing but magnetic strength multiplied by the distance between the poles. Andariki. So this is your magnetic moment in case of your bar magnet. Kani if it is not a bar magnet, if it's simply a loop, a loop lo if you are flowing some current, ante a case lo your magnetic moment will be equals to I into A bar. Ardhamaindi kada? Yes. So both are resembling the same thing. Ante enti sir? That means if you have, just a minute. Sir. So if you have a bar magnet, idigo andariki. So if this is your bar magnet, let us say this is the north pole of your bar magnet and this is the south pole. Cheppandi okasari magnetic field lines cheppandi. Something like this kada? Yes. So your magnetic field lines are something like this. Direction chuskondi okasari. Similarly, you do one thing, you take a loop. Now I want all of you to take a loop and let us say this is your loop andariki. And in this loop you are having a current I. Idigo. So in case lo your magnetic field lines through this loop also will be exactly the similar. Your field lines will be something like this. Ide kada? Yes, perpendicular to the plane of the loop and they are passing in some way. So that means you can replace this loop. ఇదిగో అందరికి. So you can replace this loop with a bar magnet. కానీ their magnetic moments should be same. అంటే ఏంటి సార్? Magnetic moment in case of your bar magnet should be equals to magnetic moment of your current carrying loop. చెప్పండి formulas అందరికి. So your I into area A should be equals to your magnetic strength into the distance between the two poles. ఇదే కదా? Yes. So మీకు length ఇచ్చినప్పుడు you can directly calculate the magnetic strength of the replaced bar magnet. So ఇక్కడ నుంచి you can simply say your magnetic strength is equals to I into A divided by 2 times the length. ఇదిగో. So this is your magnetic strength. అంటే if someone asks you what is the magnetic strength of the bar magnet represented with a loop, అంటే this is the formula. అందరికి అర్థమైంది కదా? సరే. Now what will happen if you cut the magnet? Okay, so the next topic we are going to see here is the cutting of the magnet. అందరికి చూసుకోండి. Cutting a magnet. ఇదే కదా? Yes. So as you all know, మీ అందరికీ తెలుసు కదా? Yes. So if you are cutting the magnet, అంటే if this is your north pole of the magnet and this is the south pole. So what you are doing now you are basically cutting the magnet. కానీ చూసుకోండి how you are cutting matters. Okay, how you are cutting matters. So if you are cutting it along the length, ఇదిగో. So this is the way you are cutting. అంటే if you are cutting perpendicular to the length, అందరికి ఇదే కదా? Yes. So if you are cutting this magnet perpendicular to the length, ఆ కేసులో you will simply say once you have cut it రా చెప్పండి, it automatically transforms into two different magnets కదా? Yes. So this is your first magnet and ఇదే మీ second magnet అందరికి. So this north pole remains north pole only. కానీ ఇప్పుడు this region అంటే this side will get converted into south pole, and similarly this is a south pole రా, ఇది this remains south pole only. కానీ ఈ ప్లేస్ లో చూసుకోండి this automatically gets replaced with the north pole. అంటే once you are cutting a magnet, it will automatically transforms into two different magnets. You are understanding? సరే. Volume is low ra. Okay, is it audible now? Is it audible or do you want me to? I think now it's audible. ఇదే కదా? సరే. So everybody, ఇప్పుడు చూసుకోండి, once you cut the magnet, okay, I'm writing the most important things. ఇదిగో, once you cut the magnet now transforms into two different magnets. అర్థమైంది ఇందరికి? సరే. So that means if you talk about the original magnetic moment, m bar original kada? Yes. So you are talking about the original magnetic moment. Let us say this is the first magnetic moment m1 bar and this is the second magnetic moment m2 bar. What is the relationship between your original magnetic moment and these two magnetic moments, sir? Cheppandi okasari. So you will simply say, sir, your original magnetic moment is equals to your m1 bar plus your m2 bar. Ide kada? So in case low, if you are cutting the magnet in equal halves, you will simply say that this is the relationship that will hold true. Ardhamaindi kada? Yes. Kani I want all of you to remember one thing, okay? All of you andariki chuskondi. So let us talk about the magnetic moments in the first place ra. Let us say your magnetic strength is m. What did I say, sir? In the last slide we have seen that your magnetic moment m, it is directly proportional to area. Ide kada? Yes. Ikkada chudandi. The way I have cut this magnet, all of you, what happened to the area? Area is same. Ikkada chudandi. So this area ra, can you visualize the 3D area that is there into the magnetic plane? Idigo, this area. That area is just remaining the same. No effect on that area kada? Yes. No effect on that area. You have cut it perpendicular to the length. Ante your area is same. That means your magnetic strength is also same. Ante ee case lo, if you are saying it is plus m and it is minus m kada? Yes. Here also it remains plus m only and it remains minus m only. Ekkada kuda plus m and here also it is minus m. Cheppandi okasari. So your original magnetic moment is equals to magnetic strength multiplied by distance. So let us say this distance is 2l andariki, original distance kada? Yes. So original distance 2l unte m into 2l ra, idigo. So your original magnetic moment is this. Ippudu cheppandi one by one. I want to talk about your independent magnetic moments kada? Yes. So let us do one thing. Let us shift it this side. చెప్పండి అందరికి. So what will you get? Tell me. You'll simply say, sir, your magnetic moment is, let me just wipe it out. Sorry. Yes. So ఈ కేసులో your length has been cut into half రా ఇది. So this becomes L and ఇది కూడా this also becomes L అందరికి. Your understanding? ఈ కేసులో చెప్పండి ఒకసారి, your magnetic moment m1 bar is equals to your magnetic strength into the length vector. ఇదే కదా? Yes. What about your m2 bar, sir? So m2 bar is equals to simply m, మళ్ళీ ఒకసారి for this, okay? For this. Your m2 bar is equals to, లేదా I'll write here only. m2 bar is equals to once again m into L ra. What is the relationship between m1 and m2, sir? So you'll simply say your magnetic moment, you'll simply say, sir, your m1 bar is equals to m2 bar is equals to m naught divided by 2. Why, sir? Substitute the values. ఒకసారి చూసుకోండి. So your m naught value is equals to 2ml కదా? Yes. So ఇదే మీ m naught value రా. ఒకసారి చెప్పండి, m1 value అంటే m into L and m2 value is also equals to m into L. ఇదిగో. So it is half of the original m naught value. అందరికి. Can all of you observe it? Yes. So that means your m1 is equals to m2 is equals to m naught divided by 2. ఇదే కదా? Yes. So let us take a few more questions. So let us say the question is, if the magnetic strength is M, okay? If the magnetic strength is M, full stop, find the net magnetic moment. Find the net magnetic moment. Before this, okay, before this question అందరికి, ఈ క్వశ్చన్ డిస్కస్ చేసే ముందు I want to talk something about a magnetic moment. Okay, చూడండి అందరికి, all of you. So if this is your magnet, జాగ్రత్తగా వినండి, okay, అందరికి. If this is your magnet, this is your north pole of the magnet, this is your south pole of the magnet. అందరికి అర్థమైంది? Let us say the magnetic strength is M, అంటే plus M. I'm calling it as plus M. What about other strength? This is minus M. ఇదే కదా? Yes. So your magnetic moment is a vector quantity. అందరికి. Point number 1. Your M bar is a vector quantity. Point number 1 to be noted. Okay. What is the next point, sir? The next point is, చెప్పండి. Your M bar is a vector quantity. The direction, okay. The direction of your magnetic moment vector is from south to north pole, okay? South to north pole of the magnet. అంటే the direction of this magnetic moment will be directed something like this. So this is the direction of your magnetic moment. ఇదే కదా? Yes. And the value is simply equals to, if the length is equals to 2 into L. అందరికి చెప్పండి, your magnetic moment m bar is equals to your magnetic strength multiplied by the distance to L bar, లేదా you should say L bar, something like this. అర్థమైంది అందరికి? It's a vector quantity if there are multiple magnets, okay? I am writing the 3-star mark. It's a PYQ, okay? అందరికి, it's a PYQ. If there are multiple magnets, if there are multiple magnets, what do you write? You'll simply vectorially add, okay? You simply add the magnetic moments in the vector form. Ante enti, sir? Your net magnetic moment will be equals to your m1 bar plus m2 bar and so on and so forth. Andariki, okay? Try to analyze it, sir. So let us go to the question, all of you, okay? So idigo, this is your first magnet. Let us tilt it, and this is your second magnet. Okay, right. చూసుకోండి, your south pole and this is your north pole. ఇది కూడా మీ south pole and this is also your north pole. అందరికి, okay? The question is, if your magnetic strength is M, ఇక్కడ కూడా the magnetic strength is M. Here the magnetic strength is 2m, here the magnetic strength is 2m, okay? Alright, and the angle between them is approximately 60 degrees. The length is L, ekkada kuda the length is L andariki, okay? The length is L. Find the magnetic moment. Can you try it? చెప్పండి. So this is your first question, and let us say one more question. It's a PYQ, okay? All of you, జాగ్రత్తగా చేసుకోండి. Okay? Sir. చెప్పండి. I will be back in 2-3 minutes. All of you, okay? Give me 2 minutes. You're getting it, not getting it? అందరికి. చెప్పండి. So, in your first case, we'll be talking about the directions, okay? చూసుకోండి. For your first magnet, your direction will be from south to north. ఇదిగో ఇదే మీ ఫస్ట్ మ్యాగ్నెటిక్ మూమెంట్ M1 బార్ వచ్చింది కదా. And similarly, for your second magnetic moment, south to north అందరికి ఇదిగో. So this is your second magnetic moment M2 bar. What is the angle between the two, sir? The angle between them is 60 degrees. Now, as I said, అందరికి చూసుకోండి. Your M net bar లేదా your net magnetic moment M bar is equals to the vector sum of M1 bar plus M2 bar. ఇదే కదా? Yes. So you'll simply say, sir, when you're adding these two in the vector form, you will simply say it is a root of, చెప్పండి అందరికి, root of M1 squared plus M2 squared plus 2 times of M1 times of M2 into cos theta అంటే cos 60 రా. ఈ కేసులో your cos 60 value is half. So this 2.5 is gone. And you are left with a root of చెప్పండి అందరికి m1 squared plus m2 squared plus m1 m2, right? Yes, m1 m2. కానీ చూసుకోండి, your conditions they are not similar. అంటే your m1 value, let us calculate your m1 value first. It is simply equals to m into l. And మీ m2 value చెప్పండి ఒకసారి. So your m2 value in this case is equals to 2m into l. ఇదే కదా? Yes. So you'll simply say, లేదా if you want to take the relationship, you can simply take the relationship. So instead of m2 square, instead of m2 bar, you can simply write that is equals to 2 into m1. ఇదే కదా? Values గురించి మాట్లాడుతున్నాం. అదే. Because it will be helpful in simplifying the stuff. So m1 squared అంటే it is simply equals to m1 squared. Plus instead of this m2 squared అందరికి substitute చేసుకోండి values. So m2 squared అంటే 2 times of m1 whole squared plus m1 m2 కదా? Yes. So it becomes plus m1 is m1 only and ఈ m2 కి place లో 2m1 రాసుకోండి. ఇదిగో. So everything has been simplified in terms of m1 squared. అదే do the same thing ante it will be a root of m1 squared plus 4m1 squared plus 2m1 squared ante a root of 7 times of m1 squared gone. So m1 squared root is m1 into root 7. Okasari cheppandi, what is the value of m1 sir? M1 value is m into l into root of 7. So this is your net magnetic moment andariki. You are understanding? Yes. In your second case leda in your last case cheppandi. So, and in your second case, what can you say is, yes, మీ సెకండ్ కేసులో యువర్ మ్యాగ్నెటిక్ మూమెంట్స్ ఒకసారి డ్రా చేసుకోండి. ఓకే, సౌత్ పోల్ టు నార్త్ పోల్ కదా? ఎస్. సో ద ఫస్ట్ మ్యాగ్నెట్ విల్ బీ ఫ్రమ్ సౌత్ పోల్ టు నార్త్ పోల్ అందరికి. ఇదిగో. సో దిస్ ఈజ్ యువర్ ఫస్ట్ మ్యాగ్నెటిక్ మూమెంట్ అంటే m1 బార్. అండ్ వాట్ అబౌట్ యువర్ సెకండ్ మ్యాగ్నెటిక్ మూమెంట్ సార్? సౌత్ టు నార్త్ వన్స్ అగైన్ కదా? ఎస్. కానీ ఇక్కడ చూడండి, యువర్ సౌత్ టు నార్త్ ఈజ్ ఇన్ దిస్ డైరెక్షన్ అంటే ఇదిగో సంథింగ్ లైక్ దిస్. కెన్ యూ విజువలైజ్ ఆల్ ఆఫ్ యూ? Yes, so this is your second magnetic moment, m2 bar. But, the question is, what is the angle between the two? Is this the angle between the magnetic moments? No. Why, sir? Because one is head and one is tail, kada? Yes. So, aim cheyali, sir, ee case lo shift cheyandi. Ade. So, you shift this entire vector into this side. Idigo, gone. ఇప్పుడు యూ కెన్ సింప్లీ సే దట్ ద యాంగిల్ బిట్వీన్ ద టూ మ్యాగ్నెటిక్ మూమెంట్స్ ఇస్ 90 degrees. సరే, ఒక్కసారి యాంగిల్ వచ్చిందంటే మై డియర్ స్టూడెంట్స్, వాట్ యూ డూ? యూ విల్ సింప్లీ రైట్ ద రిజల్టెంట్. ఇదే కదా? ఎస్. సో యూ విల్ సింప్లీ సే సార్ యువర్ mn net is equals to చెప్పండి, యువర్ mn net is equals to root of m1 squared plus m2 squared. This is a standard property in case of vectors. When the vectors are aligned at a 90-degree angle, so this is how you write the stuff. ఇదే కదా? Yes. So now you will simply say your m net is equals to root of చెప్పండి, what is the value of your m1 bar అంటే horizontal magnetic moment రా చెప్పండి. So your m1 bar is equals to 2 times of m times of l లేదా m times of l only. ఇదే కదా? Yes, because the length is l only. So it is simply equals to m into l. And what about your m2 bar ra? Your m2 bar is simply equals to magnetic strength చెప్పండి 2m. And what is the length between the two? 2l. ఇదే కదా? So that is 4 times of m into l. Substitute, sir. If you want to substitute, directly substitute చేసుకోండి. So m1 square అంటే ఏంటిరా? So it is simply equals to m into l whole square plus m2 square చెప్పండి ఒకసారి. Sir, it is 4ml whole square. వచ్చింది కదా? Yes. So you will simply say a root of m square l square plus 16m square l square. That is nothing but root of 17m square l square బయటికి తీసుకోండి స్క్వేర్ రూట్ నుంచి. So it is simply equals to m into l. ఇదే కదా? So your magnetic moment net is equals to ml into root of 17. Andariki, I hope you are understanding this stuff. Cheppandi, all of you, did you understand it? Okay, one నిమిషం. Sir. So this is how you do with your calculation of magnetic moments andariki. Ide kada? Yes. So let us do one thing. Okay, let us do one thing. The question states something like this. Leda, should I take the questions or let us jump to the next topic? 443. Sir, all of you, visualize. So, ఇప్పుడు there are some terminologies I'm going to talk about. Okay, there are some terminologies that I'm going to talk about. చూసుకోండి. And the name of the topic that we'll be seeing now is your Earth's magnetism. అందరికి చూసుకో. When we talk about magnets, all of you, magnet are usually referred లేదా magnetic moment or magnetic property లేదా magnetic strength. Whatever you talk about magnets ra, it is generally సాధారణంగా we'll talk about the metals only. Why? Because in case of metals ra, you do have free electrons. ఇదే కదా? Yes. And మీ magnetism chapter లో we have studied that when a charge rotates ra లేదా when a charge spins also, ఇదే కదా? Yes, it creates some magnetic field. అంటే two things are related. Students, first thing is your charge లేదా your current. ఇదిగో your charge and your magnetism is absolutely related. అంటే ఏంటి sir? That means if you are having a moving charge, ఇదిగో try to understand. A moving charge creates your magnetic field లేదా your change in magnetic field creates your moving charge. అంటే current. ఇదే కదా? Yes. So, ఈ రిలేషన్ ని అర్థం చేయడానికి we have studied the name chapter whose name is magnetism లేదా your magnetic effects of electric current. You will simply say, sir, magnetism is the name of the chapter in this case, and the reverse mechanism ra, we talked about this mechanism in your EMI, electromagnetic induction. Gurtunda andariki Faraday's laws of EMI. Your flux induced EMF is nothing but your minus d phi by dt and all these things. Flux, okay? I'm not going into the details. Ippudu chudandi all of you. When we talk about Earth's magnetism, our planet Earth andariki. So, ee planet lo we do have some layers kada? Yes. And in the central layer, you have Earth's crust. Idigo. In the Earth's crust, what is there, sir? In your Earth crust, you only have your molten lava. Andariki. Lava kada? Yes. And it is nothing but the iron. Usually you can say iron or metal. Molten metal ra. Idigo. It's a molten state kada? Yes. So you will simply say, sir, your lava is existing, kani it is in your molten state. Mari enti sir, due to this lava, sometimes what is happening is the electrons that are there into these atoms, they get aligned, and this crust sometimes behaves, not sometimes actually, this crust behaves as your magnet only. Try to understand. Andariki idigo. So your crust behaves as a magnet. And a magnet ante you call it Earth's magnetism. So now there are 3-4 important topics that we are going to discuss. Idigo. The first terminology లేదా the first term that we are going to discuss is your angle of dip. దాని తర్వాత we'll be talking something about your magnetic fields due to the earth. Okay? ఇదిగో. So when you classify this earth లేదా when you try to look at it, చూసుకోండి అందరికి. So this is your north pole of the earth కదా? Yes. So this is the north pole. What about south pole, sir? So this is your south pole. Kani these poles are the geometric north and the geometric south poles. Okay? These poles are the geometric north pole and the geometric south pole. అందరికి చూసుకోండి. If you have a bar magnet లేదా if you have your magnetic needle ra, and when you took it out, you will simply say that the magnetic needle, it gets aligned in the direction of magnetic fields kada? Yes. So you simply say that your earth has a magnet. Andariki, your earth has a magnet. Kani when you talk about the magnet inside the earth, it is situated something like this in the reverse way ra. Ante your geographical north pole has the south pole of the magnet, and your geographical south pole has the north pole of the magnet అందరికి. కానీ ఎక్కడ కూడా ఒక ట్విస్ట్ ఉంటుంది అందరికి, జాగ్రత్తగా వినండి. దాట్ మీన్స్ your south and north pole are not aligned. అంటే ఏంటిరా, ఇదిగో this angle, so your earth's magnet is aligned in a little tilted way, ఇదిగో. So this is your south pole of the magnet and this is the north pole of the magnet. అందరికి అర్థమైంది? సరే. Now it is usually said that in almost 8 crore and 30 lakhs of years in 8 crore 30 years of 30 lakh years low, your magnet has rotated ante it is continuously performing the rotation inside the earth only. So it has rotated somewhere around 183 times. Ante last time it got rotated లేదా twisted is approximately around 8 lakh years ago. And if you look at the history of humans, it is just 3 lakh years kada. Yes. So this continuously keeps on changing, idigo. So this is the geographical north and south pole line ra. And if you talk about the magnetic south and north pole line, idigo, this is the magnetic south and north pole line. ఈ యాంగిల్ గురించి మాట్లాడాలంటే this angle for our NCERT syllabus, this angle is approximately 11.3 degrees. You're understanding, everybody? You're saying something. Let me just see the chat box. Sorry. Sorry. So there are students, but I think nothing important is going on. ఇదే కదా? Yes, sir. చూద్దాం. All of you, జాగ్రత్తగా వినండి. It's not in my hands, ra. Font size already the this method, ra, I'm not habituated. Okay. Yeah, sure. Understand. I will increase. Okay, I will try to increase. సరే, ఇప్పుడు చూసుకోండి అందరికి. There are some terminologies. Number one అంటే your angle of declination. Okay, and the second term అంటే ఇదే మీ angle of dip. This is something that you have to understand andariki. Earth's magnetism law, if you are done with these two angles, that is more than sufficient. Okay, nothing more is required. Idigo. When you talk about your angle of declination andariki, what you do is your angle of declination is nothing but the angle between the planes ra. What planes, sir? The planes between your geographical north south pole and the planes between your magnetic north south pole. Let us see. Chuddam, all of you, jagrataga vinandi. Idigo. So if this is your earth, it's a sphere kada, it's a sphere. Imagine it as a sphere, all of you, and on this earth you are standing somewhere here. Idigo, you are standing somewhere here kada. Yes. Now what do you do, sir? You draw your geographical north and south pole. Ante this is your geographical north pole. Okay, and ide me geographical south pole ra. Are you understanding, sir? And what next, sir? What next? You'll simply say, you talk about, I hope it is visible, ra. Okay, is it visible? Are you able to see it, sir? చెప్పండి. Okay. Great. Now what do you do is you try to understand, all of you. Okay, so the plane ra, I'm talking about the plane. Okay, and the plane idigo, these are the 3 points on the plane. If you can visualize it needs a killer visualization, all of you. Okay, it needs a killer visualization. Try to understand. a plane that is cutting all 3 points. Idigo, this is your first plane kada? Yes, so your first plane should look something like this. Can you visualize, all of you? So this is your first plane, ra, like this. You just try to understand. If you cut the earth along this axis, there you go. Should I explain you? Not understand. It's completely, you know, the restricted scenario. Na kosame. You just visualize, right? It is the point on the earth kada? Yes, something like this. Hey, something like this. Idigo, this is your plane, all of you. Jagrataga chuskondi. This is your first plane. Ide kada? Yes, so this is your first plane. Idigo. అంటే దిస్ ఈజ్ యువర్ జియోగ్రాఫికల్ నార్త్ పోల్. అందరికి ఇదే మీ జియోగ్రాఫికల్ నార్త్ పోల్ అండ్ దిస్ ఈజ్ యువర్ జియోగ్రాఫికల్ సౌత్ పోల్. మరి యూ టేక్ వన్ మోర్ ప్లేన్, కానీ దట్ ప్లేన్ షుడ్ బి యువర్ మ్యాగ్నెటిక్ నార్త్ పోల్ అండ్ యువర్ మ్యాగ్నెటిక్ సౌత్ పోల్. ఇదిగో అంటే యు ఆర్ టేకింగ్ వన్ మోర్ ప్లేన్ దట్ ఈస్ పాసింగ్ త్రూ ఆల్ దీస్ 3 points రా. ఇదిగో ఇదే మీ సెకండ్ ప్లేన్ రా. దిస్ ఈజ్ యువర్ సెకండ్ ప్లేన్. కెన్ యూ విజువలైజ్, ఆల్ ఆఫ్ యూ? ఎస్. So this is your second plane. ఇప్పుడు whatever angle is there between these planes ra, idigo, this angle is known as theta and this angle is nothing but the angle of declination. You are understanding? Sare, so in simple words andariki, angle between planes, okay, angle between planes of your geographical and your magnetic, okay, your geographical and your magnetic north and south poles. This is known as your angle of declination, theta, okay. Sorry. Next, when you talk about your angle of dip, andariki ippudu chudandi, let us increase a little font so that you can see it clearly. In case lo I'm talking something about your angle of dip. Array, it goes good yaar. I think I should have increased the font earlier only. Angle of dip kada? Yes. ఇప్పుడు చూసుకోండి అందరికి. మీ angle of dip కోసం you take the same thing. అంటే you take the same point earth. Okay. ఈ earth లో you have your magnet రా. ఇదిగో. So this is your geographical north pole. ఇదే మీ geographical south pole. And in the earth only you have one more magnet. అంటే bar magnet కదా? Yes. So let us say this is your bar magnet. All of you జాగ్రత్తగా చూసుకోండి. And let us say this is the south pole and this is the north pole of the magnet. Andariki ippudu chuskondi, there are some terminologies ra. Terminologies ante enti? This is your south pole of the magnet, all of you. Ide this is your south pole of the magnet. Kani when we talk about earth's magnetic pole, this will again become the magnetic north pole of the earth and this will become magnetic south pole of the earth. Ide kada? Yes. Ippudu I want all of you to draw the magnetic field lines, okay, magnetic field lines. Chuskondi. Now draw the magnetic field lines. Can you tell me, all of you, the magnetic field lines ra? Idigo, starting from your north pole, something like this kada? Yes, and goes towards your south pole, something like this. Idigo andariki jagrataga try to visualize these field lines kada? Yes, very. I think I did a little mistake. Okay, yes, something like this. Are you understanding, everybody? Cheppandi. So these are the lines. Here also some similar lines will be there. First line, ide me second line, and this is your third line, and so on and so forth. I'm just drawing 3 lines for reference. Try to understand, all of you. So these are your magnetic field lines. Sir, what is the use of this? What is the use? Why do we draw about these magnetic field lines? When you talk about in natural position ante telusa mi andariki. So when you talk about the earth that is kept in a solar system, andariki idigo, let us zoom it up a little. So this is your earth kada? Yes, ide me earth ra, and somewhere here is your sun. Andariki chuskondi, this is your sun. Idigo chala big kada? Yes, so this is your sun. So what is happening, sir? The solar storm, andariki jagrataga chuskondi, the solar storm that is coming from your sun's side ra, it is carrying huge number of your ultraviolet and your radiations. You're understanding? Our radiations, if they are exposed to the human life that is there on the earth, all of us will be destroyed within a fraction of seconds. So this huge solar storm that is coming towards the earth gets completely deflected by the magnetic field of the earth. You are understanding? Ante this magnetic field of the earth, it is saving us as a shield, right? It is acting as a shield kada? Yes. So the magnetic field is acting as a shield to save the humans and the living beings on earth from your solar storm that is coming. You are understanding, sir? So this is how you simply say good. ఇప్పుడు చూద్దాం అందరికి. Now all I have to talk is your angle of dip కదా. Yes. So how do you talk about angle of dip రా? Number one. Angle of dip అంటే ఏంటిరా? It is the angle made by the magnetic field lines. అదే simply made by the magnetic field lines అంటే B bar lines రా with the horizontal. You're understanding? Magnetic field lines with horizontal. Now this is a little twist అందరికి. ఇక్కడ చూడండి, మీ హారిజంటల్ అంటే ఏంటిరా? మీ హారిజంటల్ అంటే it is a reference point, and ఈ point it is continuously different for different places on earth. ఇదిగో. So when you are talking about, let me just zoom it up if it's possible. Possible కదా? Yes. సరే. So when you're talking in terms of these regions ra andariki idigo, you try to understand. Okay, if at all a person is standing somewhere here andariki, if a person is actually standing somewhere here idigo, this is a person kada, over here cheppandi, what is the horizontal for him ra? For him the horizontal ante ide, this is a horizontal kada. Yes, so this is the horizontal for that person andariki. కానీ మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ చెప్పండి ఒకసారి. ద డైరెక్షన్ ఆఫ్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ విల్ బి డైరెక్టెడ్ సంథింగ్ లైక్ దిస్. ఇదిగో ఇదే కదా. ఎస్, సో యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ బీ బార్ సంథింగ్ లైక్ దిస్. అంటే ఇఫ్ దిస్ ఈజ్ యువర్ హారిజంటల్, యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్ లేదా బీ బార్ లైన్స్, దే ఆర్ దేర్ ఇన్ ద డౌన్వర్డ్ డైరెక్షన్. లెట్ us say this angle is phi, all of you. కన్వెన్షన్స్ చూసుకోండి ఒకసారి. When your angle is below the horizontal, ante this phi is considered as a positive angle. It's a little reverse, okay? Reverse terminology from your regular angle terminologies. And when your horizontal is something like this, and at the same time your magnetic field is here, ide me horizontal unte, this angle phi, it is in the upper direction kada, kabatti you name it as a negative angle. Andariki chuskondi, jagrataga vinandi, ide kada. Yes. So when you talk about the position number 1 ante your magnetic north pole. Idigo your magnetic north pole ante enti sir? This position. All of you jagrataga vinandi, okay? Yes. So when you talk about your magnetic north pole, the field lines are going something like this. Try to understand. So these are your magnetic field lines andariki. Where is the horizontal ra? The horizontal will be something like this. Idigo horizontal changes with the position kada. Exactly me north pole lo the horizontal looks something like this, and me magnetic field lines, they are something like this. Ante what is the angle making ra? So this is your horizontal, and your magnetic field lines are going vertically down. Ante it is below the horizontal kada. Below the horizontal unte ekkada ee place lo me angle of dip becomes plus 90 degrees. You are understanding? And at the position of your magnetic north pole, sorry, magnetic south pole, idigo, where is it sir? Okay, somewhere here, okay, somewhere here. If it's just the reverse of it. Idigo So your horizontal at your magnetic south pole will be something like this, and your magnetic field lines will be upwards. ఇదిగో ఇదే మీ B bar key lines, and here is your horizontal. ఈ కేసులో it is above the axis కదా, so negative angle ఉంటుంది అందరికి, and the value of phi will simply be equals to minus 90 degrees. వచ్చింది కదా? Yes. సరే, so you'll simply come to know. I don't know this session. Sir. So now is the last topic, Andariki, okay? Ante mostly in half an hour or 40 minutes your lecture will be completed. Andariki jagrataga vinandi kani. We have to discuss some magnetic properties ra, okay? Magnetic properties idigo andariki idi చాలా important topic. Okay, the first thing that we are going to see is your magnetic properties. Dintlo kuda the first thing that we will be talking is your magnetic permeability. All of you try to understand, all of you. ఇప్పటి నుంచి what we are doing is we are putting our normal metals, okay, or we are putting our normal metals into the external magnetic field, and let us analyze what is the trend. ఇదే కదా? Yes, చూసుకోండి. So ఎప్పటి నుంచి we are just putting our normal metals into the external magnetic field, and we are analyzing what will happen with the metals. చూసుకోండి, మీ ఫస్ట్ కేసులో దిస్ ఆర్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్స్ అందరికి. ఇదిగో దీస్ ఆర్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్, ఓకే, రిప్రజెంటెడ్ బై లెటర్ B bar అందరికి. Try to understand, okay? సరే, సో when you are having an external magnetic field, and ఈ external magnetic field లో you are putting some object, ఇదిగో అందరికి. So if you are putting any object into the external magnetic field kada, yes, then we talk about the magnetic properties. Dintlo kuda the first property is your magnetic permeability andariki. The first property is going to be your magnetic permeability. What is it, sir? I will write the definitions one by one. Here you go, okay? Your magnetic permeability is nothing but the ability of material to permit or allow, okay? Permit leda allow, to permit or to allow the magnetic field lines. You're understanding? Leda the magnetic field, simply the magnetic field through itself, through itself, idigo, through itself is known as your magnetic permeability. Okay, what are the units, sir? So ఇప్పుడు try to understand, okay? Try to understand. If your magnetic field is along this direction and you are putting the object kada, yes, so what is happening ra, some of the magnetic field lines will be passing through this object. Idigo, you are understanding? Yes. So this magnetic permeability leda this permission, we call it as your permeability, represented by the letter mu. It is the same thing as your mu naught ideal upon, you are understanding every single thing over there, mu naught ideal upon 4 pi r square, something like that, okay? Sorry. So when you talk about your magnetic permeability, you will simply say, sir, your magnetic permeability is equals to, leda there are some different terminologies also ra deentlo kuda. You have something known as your relative permeability andariki chuskondi. Relative permeability ante mu r. What is it, sir? It is simply equals to mu of the material, whatever material you are using, divided by mu naught. Mu naught value enti ra, your mu naught value is nothing but 4 pi into 10 to the power minus 7. Ide kada? Yes. So this is your relative permeability. Units gurinchi maatladalante the unit is Tesla meter per ampere. Idigo. And when you are talking about the permeability of the material, it is some internal magnetic field will be developed inside this material. Idigo andariki based on the same development we are classifying your objects into paramagnetic, diamagnetic and ferromagnetic substances. Sir, let us say the magnetic field induced is Bm material kada, magnetic field inside the material ante Bm ra, and your external magnetic field is equals to simply B. Ide kada? Yes. So you will simply say that your relative permeability, idigo, your relative permeability is nothing but the magnetic field in the material divided by the external magnetic field B. This is a formula for your relative permeability. You're understanding, sir? Let me see now what you're telling. Okay. Yes, I think we can proceed next. Okay, sir. So the next property that we'll be seeing andariki, your magnetic permeability is completed. Let me quickly revise it. And idigo andariki, when your object, okay, when your object is actually placed into the magnetic field, how many field lines ra? If there are 10 field lines, are 10 field lines lonchi, how many field lines will be passing through this object is known as your magnetic permeability. Point number one. Point number two ra, it only depends on the material, okay, not on the magnetic field. Ante, when you're talking about your magnetic permeability, we will just be focusing on the material ra. How many field lines were thrown? N. How many of them passed through this object? That ratio is known as the relative permeability of it, and your value is for your mu naught, ante the magnetic permeability of your vacuum లేదా free space is simply equals to 4 pi into 10 to the power minus 7. ఇదే కదా? Yes. So you try to understand, if your magnetic field lines, they are n in number, మొదటిగా I am taking n number of lines, ఇదిగో అందరికి n number of lines, ఇదే కదా? Yes. Now when I'm putting the external when I'm putting the material, all of you, into this external field, what is happening ra? Some field lines are getting developed into this material kada? Yes. So that how many field lines are developed ra? Idigo. So if there are only 2 field lines, that you will say that, sir, in case low, your magnetic permeability is low. If your induced field lines are more, you will say your magnetic permeability is more. You're understanding? Ade, how many field lines are induced? Ante me magnetic permeability totally depends on the material. So whenever we talk about permeability, we'll be seeing your material. Ide kada? Yes. Similarly, let us talk about the next important property, that is known as your magnetization. Idigo andariki. You're understanding? Leda your magnetizing force, or it is also known as a magnetic intensity. Represented by the letter H ra. ఇప్పుడు చూడండి, same thing, experiment is the same. అంటే we do have some external magnetic fields. Our external magnetic field we are putting some object. What is happening, sir? There will be some induced magnetic field into that object. Ade kada? Yes, same thing, exactly the same thing. Idigo. So if this is your external magnetic field B bar, and ఈ external magnetic field లో if you are putting some object అందరికి, and let us say ఆ object లోంచి there are some magnetic field lines induced, ఇదే కదా? Let us say B induced లేదా B of the material. Your magnetic force, magnetizing force లేదా magnetic intensity అంటే ఏంటిరా? It is simply the strength of the external strength of, idigo, try to understand, all of you, it is nothing but the strength of your external magnetic field. Ade, simply finished. Okay, external magnetic field B bar. What strength, sir? The strength to produce the magnetic field inside this material. Ade, you're understanding? The strength of the external magnetic field to produce magnetic field into the normal metal is known as your magnetizing force లేదా మీ magnetic intensity. కానీ ఇప్పుడు చూడండి, what is the difference between this and this, sir? ఈ కేసులో when you're talking about your magnetic permeability, ఆ కేసులో we will only be observing this material. అంటే external magnetic field is fixed రా. ఒకసారి you take one material, see how many lines are passed. దాని తర్వాత you take another material and see how many lines are passed. ఇదే కదా? Yes. So the material that is allowing more number of lines to pass, you will say that the magnetic permeability is more for that material. Understanding everybody? Yes. And in your magnetizing force లేదా magnetic intensity, we don't change the material ra. What we do, we take the same material. ఒకసారి you turn on first magnetic field, you see how much number of field lines are induced. దాని తర్వాత you change another magnetic field, bring another magnetic field and see how many number of field lines are induced. అదే కదా? Yes. So you will simply say your strength of external magnetic field to induce లేదా to produce the magnetic field lines, ఇదిగో the magnetic field lines, B bar lines కదా? Yes, the magnetic field lines in a neutral, అందరికి in a neutral metal is known as your magnetizing intensity. లేదా you also say the strength of the external magnetic field to magnetize the material. You are understanding? To induce in magnetic field lines లేదా or to magnetize the material, both mean the same అందరికి. ఓకే, లేదా to magnetize the material. అదే, I hope you are understanding. ఇప్పుడు చూసుకోండి, all of you జాగ్రత్తగా వినండి. ఓకే, your magnetic intensity is given, it's a formula అందరికి. it is nothing but your magnetic field, external magnetic field రా, ఇదిగో external magnetic field B bar divided by your mu naught, B naught upon mu naught. అంటే external magnetic field divided by the magnetic divided by mu naught. mu naught అంటే permeability, అదే కదా? Yes. లేదా you will simply say if your another magnetic field లేదా it's there for your another material రా, material mu naught అంటే permeability of the material, ఇదే కదా? Yes. So if you are having some another material, ఆ material కోసం the value of the permeability is not mu naught, అంటే ఆ కేసులో you will simply say sir H is equals to whatever magnetic field you have divided by the mu of the material. mu of the material అంటే permeability of the material. You are understanding, all of you? Sir, let me see the chat box now. Okay. Good. Yes. So the next property రా, next property చూద్దాం. next property అంటే property number 3 and you call it as your magnetizing intensity. అందరికి there are some confusing terms, okay, don't get confused. The first one is your magnetic permeability. దాని తర్వాత we talk something about your magnetizing force లేదా your magnetic intensity. And next term that we'll be talking about is your magnetization. Okay, your magnetization intensity. Okay, represented by the letter I bar. What is it, sir? Ade, the same thing, ra, same thing. If you are having the external magnetic field, okay, external magnetic field, external magnetic field వల్ల this material లేదా this metal, it will convert into a magnet కదా? Yes, try to understand. Okay, try to understand once again. It will try to convert into magnet రా, magnet. ఇదిగో, if this is your external magnetic field అందరికి, there is a little difference between all of them, okay, but you must be conceptually good రా. ఇదే నా material ఉంటే try to understand. Okay, the ఇంటెన్సిటీ అంటే ఏంటి? ద స్ట్రెంగ్త్. ఇప్పుడు చూడండి, వెన్ యూ ఆర్ హ్యావింగ్ ద ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్, you are putting the material into the external magnetic field. What is happening, sir? Due to the external magnetic field, this non-magnetic material, it got converted into magnetic material kada? Yes. Ade. The strength of this magnetic material is known as your magnetization intensity. You are understanding? The amount of magnetization, idigo I'm talking about amount, okay? Amount ante the strength, leda you write strength also ra, don't get confused, okay? The amount or strength of magnetization ra, ide kada? Yes, the amount or strength by which an object, leda a material, okay, an object is magnetized ra, your understanding, is magnetized in presence of your external magnetic field. Ide kada? Of external magnetic field B bar. And if this is magnetic field B bar, you will simply say your intensity is the amount of strength by which your object is magnetized, లేదా the strength of the magnet. Now the question is, how do you calculate the strength of the magnet, sir? The strength of the magnet is calculated by the magnetic moment ante the magnetic dipole ra, ade the same thing. Idigo. So when you consider the parameters to calculate the strength kada? Yes. So if this is the length between the poles andariki, and let us say induced magnetic field kada, ఆ material లో ఉంటే induced magnetic field కోసమే the poles are first pole strength m, ide the second pole strength m kada? Yes. Try to understand. This automatically becomes the north pole, this automatically becomes the south pole. Andariki chuskondi. You are understanding? Now what you do is your magnetization intensity I is given as your magnetic moment m bar divided by the volume of this magnet. You are understanding, sir? Ippudu when you talk about your m bar is nothing but your magnetic strength multiplied by 2L kada? Yes. So divided by volume cheppandi okasari. Sir, if the area of this magnet is A, idigo try to understand, okay? If the area of this magnet is A and the length is 2L, all of you jagrataga cheppandi okasari. What do you say about the volume ra? Volume is area into height kada? So area is A and the height is 2L only. So ikkada nunchi 2L gone. You will simply say it is magnetic strength upon the area of the face perpendicular. Ide kada? Try to understand. So this is known as your magnetization intensity. There is one more formula. If you want, try to understand that formula also. So your magnetic intensity I bar is nothing but, you simply say it is equals to B bar upon mu. Understanding? Leda mu naught. What is this B bar, sir? B bar ante it is the induced magnetic field andariki. Induced magnetic field in the material. You understanding? Right. So this formula leda this formula both represent the same terminology, magnetization intensity I. You understanding, sir? So as I said, all of you, your magnetic strength is directly proportional to area. And if your magnetic strength is decreasing, that means your area is also decreasing. Ade kada? Yes, sir. Right. Let me see the charts. After every single point, sir. So now let us move towards the next topic. Andariki, how many topics are done now so far? 3 topics kada? Yes. Let us talk about your fourth topic, and the name is the magnetic, okay, magnetic susceptibility. చెప్పండి ఒకసారి. Your magnetic susceptibility is usually represented by the letter chi, chi, chi kada, yes. In your magnetization intensity, what did we discuss, sir? We talked about how strong, okay, how strong the magnet becomes in presence of external magnetic field. Kani, when we talk about your magnetic susceptibility, it is the rate ante telusa. You will simply say your magnetic susceptibility is the major, okay. Your magnetic susceptibility is the major, all of you, is the measure of how quick, you're understanding, yes, how quick లేదా how fast the material is magnetized. The material is magnetized, అదే sir. And here you'll simply say your magnetic susceptibility is simply equals to I upon H. H అంటే ఏంటి sir? You're understanding? Your H ante your magnetic intensity and your I ante your magnetization intensity. You remember the formulas only, okay. Do you have any more doubts? You tell. Sir, no more doubts. Sir, so let me write the formulas, all of you, okay. Let me just write the formulas. Your value of H can be written as your B upon mu లేదా B naught upon mu naught kada, yes. And at the same time your value of mu is written as the magnetic field induced in the material ra divided by mu naught. ఇదిగో సో ఇక్కడ నుంచి this B is your external magnetic field, okay, గుర్తుపెట్టుకోండి. And this B అంటే it is the magnetic field induced. difference గుర్తుపెట్టుకోండి అందరికి. సో ఇక్కడ నుంచి if your material is placed in an external magnetic field, అందరికి చెప్పండి ఒకసారి. So if your material is placed in the external magnetic field, you will simply say that the total magnetic field will be equals to the external magnetic field plus magnetic field induced kada, yes, చూసుకోండి. అంటే ఇక్కడ నుంచి find the value of B and find the value of BM. So sir, here you will simply say H into mu should be equals to external magnetic field, and at the same time you will simply say sir I into mu naught should be equals to your induced magnetic field. ఇదే కదా, yes. So this is your B net ra, B net ఇదిగో. So your B net is equals to, all of you try to understand, this is your external magnetic field kada, H into mu. All of you జాగ్రత్తగా వినండి. So you will simply say sir, 1 minute, okay. Yes, sir. So sir, your B net will be equals to, yes, your B plus BM. ఈ కేసులో if you are talking about magnetic field external, sir, external magnetic field కోసం it is in the air, అంటే in the vacuum రా, ఆ field కోసం you will simply write sir air ఉంటే your mu naught will be represented and ఆ కేసులో your H will be represented. H అంటే the magnetic intensity, ఇదే కదా, yes. So sir, your net magnetic field B H into mu should be equals to H into mu naught plus BM అంటే I into mu naught, ఇదిగో. So ఇక్కడ నుంచి you will simply say sir your H into mu is equals to mu naught into in bracket H plus I. When you simplify this formula, all of you, you will get a result, and I want all of you to remember the result only, okay. The result is mu relative is equals to your magnetic susceptibility plus 1. ఇదిగో. It has been asked in multiple PYQs and multiple questions. ఇదే కదా, yes. So just remember this for now, and yeah, done actually. The next thing that we'll be talking is the properties లేదా the magnetic properties of the material. ఇదిగో అందరికి the magnetic properties of a material. So basically a material can be classified in three different types. అంటే మూడు రకాలు ఉన్నాయి. The first type of the material is your diamagnetic material. అందరికి ఇదిగో the first type అంటే మీ diamagnetic. Your first type is diamagnetic materials. దాని తర్వాత we talk something about your paramagnetic materials. ఇదే కదా? Yes. And lastly we talk something about your ferromagnetic materials. అందరికి చూద్దాం one by one. What is this diamagnetic, what is this paramagnetic, and what is this ferromagnetic? Point number 1, ఇదిగో జాగ్రత్తగా వినండి. There are some terminologies that you want to understand. Your diamagnetic అంటే it simply repels in presence of external magnetic field. అంటే ఏంటిరా, if this pen is your diamagnetic material, అందరికి జాగ్రత్తగా వినండి. ఓకే, and let us say this is your north pole, ఇదే మీ సౌత్ పోల్ రా. ఈ రెండు magnets కి మధ్యలో you are putting this pen. So what happens, sir, if your pen is diamagnetic, it will try to repel కదా, repel from both the sources. అంటే when you put your diamagnetic material in the external magnetic field లేదా north and south poles, it will align itself perpendicular to the lengths of the magnetic poles. అదే కదా? yes. So మీ diamagnetic కి కేసులో your mu relative value is less than 1. Point number 1 to be noted. Okay, point number 2, I am writing everything in a single clinch. చూసుకోండి. Point number 2 to be noted is it aligns in the direction that is perpendicular to your external magnetic field. Point number 1 to be noted. ఇదే కదా? yes. When it comes to your paramagnetic substances, your mu value is greater than 1. అంటే there will be slight magnetization of this material. Try to understand. అంటే ఏంటిరా, we'll see everything in detail. I'm just giving you the introduction. And it aligns in the direction of V bar. అదే, so it aligns in the direction of V bar. Point number 2 to be noted. Okay, in the direction of your external magnetic field V bar. Point number 2. And lastly, when you talk about ferromagnetic substance, this is the highest magnetization substance. Ante entira, in a ferromagnetic substance, when you put it in the external magnetic field, the highest amount of magnetization happens. Ante if you have a paramagnetic substance and a ferromagnetic substance, ee rendudni kuda you place it in the external magnetic field. కొంచెం సమయం కోసం యూ ప్లేస్ ఇట్, దాని తర్వాత రిమూవ్ చేసిన తర్వాత యూ క్యాలిక్యులేట్ ద మ్యాగ్నెటిక్ మూమెంట్స్ ఆఫ్ బోత్ ఆఫ్ దెమ్. సో ఇఫ్ ఇట్ ఇస్ అ పారామాగ్నెటిక్, ఇట్ విల్ హ్యావ్ అ లెస్ మ్యాగ్నెటిక్ మూమెంట్. If it is a ferromagnetic, it will have high magnetic moment. Why, sir? Because the induced magnetic fields are massive in terms of your ferromagnetic substances. Ante your mu r value is very high. Ante it is much more than 1, and migita conditions are the same. Ante it also aligns the same direction. You're understanding? In same direction. Ade same direction of V bar. Ante your external magnetic field. Ippudu let us take one by one cases and let us try to discuss all of you. The first type is your diamagnetic substances. చూసుకోండి. When I'm putting this diamagnetic substance in the external magnetic field B bar, ఇదే కదా? yes. So this is your external magnetic field B bar. అందరికి. Now what I'm doing is I'm actually placing this in the external magnetic field. What is happening, sir? ఏమైతుంది అంటే there will be the magnetic field induced. అందరికి చూసుకోండి. yes, magnetic field is also induced in diamagnetic also. కానీ the direction of the induced magnetic field is opposite to the direction of the external magnetic field. This is the most important topic you have to understand. ఇప్పుడు చూసుకోండి, when your external magnetic field is to the right side, the induced magnetic field in your diamagnetic substance will be somewhere around the left side. Sir, what is happening due to this ante your magnetic field lines, they are scattering away ra ante after some time when you analyze the situation, the number of magnetic field lines that are huge, చూసుకోండి, all these magnetic field lines are passing kada, as soon as they cross this magnet they get scattered and they come out again, something like this. This is something that's happening. Okay, try to understand. This is the phenomena happening. Ante this induced magnetic field lines, it is cancelling out, లేదా it is decreasing the number of external field lines from itself. Kabatti when you talk about the magnetic field strength లేదా magnetic field intensity, it is directly proportional to the number of magnetic field lines kada. Yes, ikkada chudandi. So when you take a cross sectional area, you will have, sir, 1 2 3 magnetic field lines ra. Ade you shift the same area over here, you will find only no magnetic field lines. You are understanding? Almost zero magnetic field lines. Ante your diamagnetic substances, they simply don't like your magnet. You are understanding? Ante your diamagnetic substances, they repel from your magnet లేదా your magnetic fields. It's all up to you. Okay, now all of you have to understand the examples of your diamagnetic substances. So the examples include your antimony, then your bismuth, okay, copper, and then you also have your quartz, and so on and so forth. Okay, Kani, I want all of you to remember the examples. Okay, let me just see the chat once again. I hope you are understanding ra. Andariki cheppandi okasari. Yes. So we talked about the values kada. Yes, we talked about the mu value andariki. So mu relative is less than 1 kada, and it will be 0, more than 0. What is the relationship between your susceptibility and mu ra? Okasari chuskondi. Can I simply say your magnetic susceptibility is equals to mu minus 1 ra? Idigo, you are understanding? Sorry. So you'll simply say, sir, your chi m depends లేదా it lies yes. So yeah, so you'll simply say that your magnetic susceptibility is less than 0. Okay, and even if you want to see the left term, you can simply say minus 1 to 0 ra. So these are the terminologies. Idigo, I'm quickly revising. Point number 1 andariki. So if your material is a diamagnetic material, place it into the external magnetic field. ఏమైంది సార్? పాయింట్ నెంబర్ 1, it is inducing a magnetic field. కానీ that magnetic field is in the opposite direction. కాబట్టి the total number of magnetic field decreases. అంటే it repels the magnet. And when it's a diamagnetic material, you are suspending it. ఇదే నా నార్త్ పోల్, దిస్ ఈజ్ మై సౌత్ పోల్ సార్, అండ్ ఆటోమేటికలీ దిస్ మటీరియల్ విల్ గెట్ అలైన్ ఇన్ అ పర్పెండిక్యులర్ డైరెక్షన్. ఇదిగో సంథింగ్ లైక్ దిస్. యు ఆర్ అండర్స్టాండింగ్? ఎస్. అండ్ అట్ ద సేమ్ టైమ్ యూ విల్ సింప్లీ సే దట్ యువర్ diamagnetic materials, they are magnet repellent, and you are also include, you can water also. Okay, water also, it is your diamagnetic material. Andariki try to understand. So let us talk about the next term, leda the next type of material that we have is your paramagnetic materials. Andariki ide kada. Yes, ఇప్పుడు చూసుకోండి, you can simply say that your paramagnetic material is a neutral one. Neutral one ante entira, it stands between your diamagnetic and ferromagnetic. Ante entira, is it attracted towards the magnet? Yes, but not more. Sir, what is the value of mu for this? Your mu value is greater than 1. Ade not too high also, something similar to the value of 1, slightly greater than that. Sir, is the magnetic field line induced? Yes. Is it more? No. ఇప్పుడు చూడండి, let us go and let us quickly discuss everything about your paramagnetic material. అందరికి చూసుకోండి. So if these are your magnetic field lines, B bar అంటే external magnetic field lines కదా. Yes, so this is your B bar external ra. ఈ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్లో వెన్ యూ ఆర్ పుట్టింగ్ a paramagnetic material, అందరికి చూసుకోండి ఇదే నా paramagnetic material కదా, yes, that means what is happening sir, the strength of this induced magnet is usually low, point number 1. Point number 2, the speed also ra, ante it will not quickly become a magnet, it will slowly try to become a magnet, ide kada, yes. So your magnetic field induced is almost in the same direction, point number 1, okay, point number 1 to be noted ra మీ paramagnetic case లో. లేదా you will simply say sir it will allow కదా, permeability రా, permeability అంటే ఏంటి సార్, permeability అంటే how many number of magnetic field lines are passing through the object, అంటే how much field lines it is allowing, లేదా it is permitting రా, permitting కదా, yes. So it will happen sometimes రా, ఇదిగో in case of your diamagnetic material the field lines were running away కదా, కానీ మీ పారామాగ్నెటిక్ కేసులో ద ఫీల్డ్ లైన్స్ యాక్చువల్లీ విల్ రన్ టువర్డ్స్ ద మ్యాగ్నెట్ రా, ఇదిగో సంథింగ్ లైక్ దిస్, ఓకే. సో ఇఫ్ దిస్ ఈజ్ యువర్ ఎక్స్టర్నల్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇట్ విల్ పాస్ త్రూ ద మ్యాగ్నెట్, అరే if this is your external magnetic field it will pass through the magnet, something like this, try to understand andariki, is it kada, yes. So point number 1 ra, idigo the value of mu r is generally greater than 1. Mu r greater than 1 unte enti ra, what is the relationship between your magnetic susceptibility sir, your chi m is equals to mu r minus 1 kada, ante your magnetic susceptibility is greater than 0 for this paramagnetic material, point number 1 to be noted. Point number 2 ra, point number 2 andariki jagattaga vinandi, point number 2 is it will induce some magnetic field but that magnetic field will not be strong. Point number weak magnetization, అదే కదా, yes. చెప్పండి థర్డ్ పాయింట్ రా, it aligns, yes, it aligns in the direction of external magnetic field, B bar, you understanding, సరే. That means if this is your south pole, andariki ide మీ south pole and this is your north pole kada, yes, and when you have a paramagnetic material what is happening sir, what is happening ante if this is your paramagnetic you are tying it with the help of a string ra, string kada, yes. So what is the position it is acquiring ra, idigo this is the final position of your bar magnet లేదా your paramagnetic substance, ide kada, yes. So the alignment is in the direction of your magnetic poles, ide kada, yes. There is one more thing andariki I want all of you to understand, that is the demagnetization, try to understand, okay. Sir, what do you mean by demagnetization sir? Your demagnetization case lo, even if you have a magnet, does not matter how strong, does not matter how weak, ఒకసారి if you are heating that magnet అంటే the magnet will lose its magnetic properties, you are understanding, అంటే if you are increasing the temperature automatically the magnetic properties will be decreased, అదే కదా, yes. And for a paramagnetic substance when you see the graph of these magnetic properties లేదా your susceptibility versus temperature ra, the graph looks something like this, అంటే ఏంటి సార్, your magnetic susceptibility is inversely proportional to the temperature, you are understanding, point number 1 to be noted. So all the quick revision రా చూసుకోండి, your paramagnetic materials they are neutral, అంటే not highly repelling, not highly attracting, చిన్న attractions ఉన్నాయి ఆ కేసులో. Point number 2 ra, when you are putting that paramagnetic substance in presence of the external magnetic field, akkada what is happening is your magnetization of the paramagnetic substance is happening, కానీ the magnetization is very small, చూసుకోండి values కూడా చూసుకోండి, అంటే your magnetic susceptibility is slightly less than 0, అంటే near about 0 only, కానీ not too much high, you are understanding, sir. And the third thing that you are having is it will align itself, కానీ the alignment will also be very slow ra, You're understanding? It will align for sure. ఇదిగో ఇదే మీ నార్త్ పోల్, దిస్ ఈజ్ యువర్ సౌత్ పోల్, దిస్ ఈజ్ యువర్ పారామాగ్నెటిక్ మెటీరియల్ కదా. ఎస్, it will align, but that alignment will be very slow, something like this. You're understanding? And when you see about your last topic and last type of it, this is known as your, hey, did we take some examples, Ra? Did I give you some examples? Here you go. The examples of your paramagnetic material. Cheppandi all of you. The first one is your aluminium. Ide kada? Yes. And remaining ra, aluminium. And then you have your chromium. Manganese kada? Yes. ETC. Lithium and platinum, and so on and so forth. Okay, you can do it by yourself. The next topic that we have to talk about is your ferromagnetic substances. Andariki. Chuskondi. Ferromagnetic substances are the highest substances that get attracted towards the magnet, I should say simply. Ide kada? Yes. Ante if you are putting the ferromagnetic substance in presence of the external magnetic field B bar, idigo andariki. So if this is your external magnetic field, and let us say here is your substance ra, ide kada? Yes. So what is happening, sir? From this ferromagnetic substance, a large number of field lines will be passing. Idigo. You're understanding? Ante your magnetic field lines will be massive through this ferromagnetic substance. Try to understand. Point number 1. Ide kada? Yes. Point number 2 ra. Point number 2. Try to understand. It is strongly attracted. It is strongly attracted towards the external magnetic field. Ide kada? Yes. Point number 1. Point number 2, sir. What about the alignment? Alignment kosam chooskondi. If this is your north pole, this is your south pole, like this, it will quickly align itself in the direction of your magnetic field lines. Idigo. So you'll simply say, sir, if this is your north pole, ide me south pole unte, you'll simply say, you tie it with a string kada? Yes. So if it's a string andariki, it will quickly align itself in the direction of the string. Ide kada? Yes. Leda, you'll also say simply the magnetic field lines, under the external magnetic field lines, whatever are there, they are strongly attracted by the ferromagnetic substance. Okay? Yes. And the best example is your iron only. Okay? The best example is your iron only. What about the value, sir? Your mu r value is much more than 1. And what about the value of your susceptibility? It is equals to mu r minus 1. And still your susceptibility value will be much more than 1 also. E case lo kuda the same thing. You are understanding? Sir. So you'll simply say that there is one more formula andariki. I want you to remember this formula. Okay, your magnetic susceptibility is C divided by T minus TC. TC ante your Curie temperature. Once your Curie temperature has been achieved, okay, once your normal temperature is more than that Curie temperature, what is happening? I've told you earlier also, even if you have a neodymium magnet, that is one of the most strongest magnets kada? Yes. So even if you have your neodymium magnet, you're heating it, ante the magnetic strength is definitely going to reduce. Point number 1. Point number 2 ra, ippudu ee ferromagnetic substances ni if you start them heating, ante they will also lose their ferromagnetic properties. Ante okasari your temperature has been above the Curie temperature. Curie temperature ante the temperature at which it will lose its state. Ade kada? Yes. So you will simply say, sir, aa case lo the ferromagnetic substance will be converted into your paramagnetic substance. Idigo. Ide kada? Yes. So this is something that you have to understand. Andariki, I hope it is understandable. Ide kada? Yes. Give me 1 minute, okay? Let me see charts. ఏదైనా చెప్పండి రా. Are you listening to me, all of you? Are you listening to me? Am I audible? Hello, 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 hello. No reply is happening at all. ఇదే కదా? Yes. సరే. Now, let us talk something about your hysteresis curve, okay? Clear, sir. Okay. Sorry. Good. So the last topic, dan tarvata our chapter will be completed, okay? Choose good. The topic name is your magnetic hysteresis. Spelling cheppandi okasari. Is the spelling correct? Hysteresis kada? Yes, hysteresis. Sir, chuddam. What is this, sir? Point number 1 to be noted. Idigo. When you talk about your magnetic hysteresis, it is understood that you are talking only about the ferromagnetic substances. Ide kada? Yes, because ferromagnetic substances give us the clear-cut boundaries regarding your magnetic field intensity and your total magnetization. Ide kada? Yes. So point number 1 that we'll be talking about is your ferromagnetic substances. Idigo. Let us do an experiment, all of you, okay? This is my ferromagnetic substance. Idigo. Ide na ferromagnetic substance kada? Yes. I'm putting this ferromagnetic substance in presence of the external magnetic field. Andariki. B bar. Ide kada? Yes. I'm putting this ferromagnetic substance in presence of the external magnetic field. What is happening, sir? If your object, లేదా if your material is a ferromagnetic substance, ఆ కేసులో the normal material లేదా the non-magnetic material is slowly turning into the magnetic material. అదే కదా? Yes. That means slowly and slowly the magnetic field of the material keeps on increasing. ఇదిగో. So the same phenomena, the same phenomena I want you to understand through a graph. Andariki chuskondi. So if this is your graph and this is the external magnetic intensity, basically, ide kada? Yes. And this is the magnetic field induced in the material BM ra. Andariki chuskondi. Now what you are doing, sir? Your external magnetic field ante magnetizing intensity ra, H. Idigo. What you are doing now is, sir, you are slowly increasing the value of this value of H. When you are slowly increasing it, ante slowly the impact of this external magnetic field is also increasing on that material. Ide kada? That means when you are slowly increasing the value of H, idigo, 0 kada? 0 nunchi when you are slowly increasing it, automatically the magnetic value leda the induced magnetic value is also going to increase. Idigo. Right? Yes, yes, something like this. Try to understand. Yes. So when you are slowly trying to increase, idigo, at t is equals to 0, let us say the value of H was 0. And we started from the 0 point. Kada? Yes. Slowly you have increased the value. Let us say from t is equals to t naught, your value became H is equals to H naught. Ante ide. This is the maximum value of the external magnetic field. Ante telsa andariki. So this is the maximum intensity you are exposing. Ante this value is H equals to H naught. Now you stopped. You said it's okay. Now it's too much. Well, let us do one thing. Let us go back. Back ante entira. You are decreasing the magnetic intensity. Idigo. This is the direction kada? Yes. Now what you are doing, sir? You are decreasing the magnetic intensity. Leda, you are magnetizing intensity. Ade. So when the value of it is decreasing, the expectation, cheppandira, when your H value is increasing, B value is also increasing. Now when your H value should decrease, me B value it also should decrease kada. Yes, so let us see. Yes, it happened the same way ra. Idigo, so when you are decreasing the H value, the B value was also decreasing, and we got this point. అందరికి చూసుకోండి. అంటే ఏంటి సార్, ఆ పాయింట్లో ఒకసారి చెప్పండి వాట్ ఈస్ ద హెచ్ వాల్యూ రా, డ్రా ఆఫ్ ద పర్పెండిక్యులర్. సార్ ద హెచ్ వాల్యూ ఇస్ 0 అంటే తెలుసా, దాట్ మీన్స్ when you are having a scenario, what scenario ra, at t is equals to 0, h equals to 0 ante b value is also equals to 0 ide kada, ante induced magnetic field is also equals to 0. You are increasing the h value, maximum value ochindi h naught, a maximum value kosame your maximum value bm naught it is also has been achieved. Ante let us say this is the maximum value andariki ide kada. Yes, so bm naught is the maximum value. Dan tarvata what you are doing is you are slowly decreasing the intensity. Now it was my stage number 1. Idigo andariki stage number 1 ide kada. Yes, me first stage lo you increase the value of h, automatically the magnetic field also increased. Dan tarvata me stage 2 lo what you are doing is cheppandi, slowly you are decreasing the value of h is equals to h naught to h is equals to 0 ra, ante you are decreasing the magnetic strength, ante the number of magnetic field lines are less. Now what is expected, sir, your magnetic field inside the substance it also should decrease to 0 ade kada. Yes, so the magnetic field B is equals to bm naught, it went from bm naught to let us say at some magnetic field bm. Idigo, you are understanding? So when the external intensity was 0, the induced magnetic field was not 0. Ante whatever damage you have done, leda whatever change you have done in the magnetic field has not been compensated. Ante enti ra, the damage has been done ide kada. Idigo, this is the damage ra, maximum value increase అయింది. magnetic field గురించి మాట్లాడుతున్నాం అందరికి చూసుకోండి y axis లో. Now when you are decreasing it, the value remained at this point only. Understanding? Until this change has happened ra. Idigo, try to understand, this change has happened andari. Understanding? This change has happened. Now what you are doing, sir, now you are focus లేదా మీ గోల్ ఏంటంటే you have to make this value 0. అంటే which value రా, this value, అంటే you have to bring it to the x-axis. మరి ఏం చేయాలి సార్, you have to remove the magnetic field అదే కదా. yes, so what do you do, sir, ఈ కేసులో your induced magnetic field is still there in the material ఇదే కదా. చూసుకోండి, here it has maximum రా, maximum. Now when you are decreasing the field అంటే external intensity, your magnetic intensity in the substance also decreasing కానీ not 0. Final case lo let us say this is the intensity left, mari you have to remove it also kada. So aa case lo you apply the reverse magnetic fields. Chuskondi ante negative magnetic fields kada. Yes, so aa case lo your magnetic fields are reverse. Reverse ante in the opposite direction ra. What about your material, sir? ide me material ante ide ra, and in this material you are having some induced magnetic field kada. Yes, so this is some induced magnetic field. Now what will happen, sir? First induced field is in the right side, your magnetic intensity external is in the left side. They will oppose each other and they will fight, and there will come a time for sure. And your magnetic moment లేదా the magnetic intensity, magnetic field in the substance will become 0. కానీ that will be achieved by applying the negative magnetizing intensity kada. Yes, so the negative magnetizing intensity will look something like this. The graph goes on something like this. You are understanding? Our point low, your bm value has become 0. Try to understand, everybody. Yes, our point low, your bm value has become 0. Ippudu there are two terminologies that I want you to visualize ra. This first value ra, which color should I take? Pink color. Yes, this first value ante when your external magnetizing intensity was 0, ఆ కేసులో the magnetic field was there కదా. Yes, you name this as the retentivity. అందరికి retentivity అంటే ఏంటి సార్, when you are applying magnetic field it is getting magnetized. When you are decreasing the magnetic field it is not getting completely demagnetized రా, అంటే కొంచెం magnetic field is there that remaining magnetic field is known as the retentivity of the magnet, లేదా the substance. You understand? Yes. Now what do I have to do? To remove this remaining magnetic field, you apply the opposite magnetic field. Ade. So sir, at what opposite magnetic field the complete magnetic field is getting zero, and a complete demagnetization is happening. External magnetic field ni we are calling it as the coercivity. Idigo. This terminology is known as, I should not write here. This terminology kada, this length లేదా this value ra, this is known as the coercivity of the substance. Yes. Now when you look at the more phenomena, something like this, what is happening, sir? Now what do you do, sir? You keep on decreasing the value of the magnetizing intensity. అంటే ఏంటిరా, మొదటిగా your magnetizing intensity was to the left side, whatever direction for you it is, okay? Slowly the magnetic property started arising ra. దాని తర్వాత you decided to make it to zero. So your external magnetic intensity became zero, కానీ your ferromagnetic substance, దీంట్లో your magnetic field did not become zero. ఆ ప్రాపర్టీని you call it retentivity. What do you do? To remove this extra magnetic field, you have applied opposite intensity and negative intensity. Ade. So due to the presence of this opposite intensity, the magnetic field is decreasing and becoming zero. Ade kada? Yes. Now whatever extra magnetic intensity is required, that is known as the coercivity. Now what you are doing is you are again increasing the magnetic intensity in the same direction, just to see what is happening, okay? If you are again increasing it, it will go on again something like this, and this will be the maximum value. ఆ value పై వచ్చిన తర్వాత you will say, sir, this is your maximum intensity H0, and at this time your maximum magnetic field induced is minus Bm0. You are understanding? Ade. Now what you are doing, sir, you are slowly trying to bring it at the same level. Try to understand, andariki, okay? You are slowly trying to bring it at the same level. Mari emaitadi, sir? The graph will look something like this. Idigo. Try to understand. So this is your hysteresis curve. Andariki jagrataga vinandi, okay? Just remember this. So this is your hysteresis curve, లేదా hysteresis graph also. ఇదే కదా? Yes. Now based on the area of this graph, అందరికి జాగ్రత్తగా వినండి, based on the area of this graph there are some terminologies. అంటే ఏంటిరా, we talk about the strong magnets and we talk about the weak magnets. ఇదిగో. So classification of substances కదా? Yes. Classification of magnets లేదా substances, it's all up to you. The first type is your strong magnets. అందరికి చూడండి, and the second type is your weak magnet. ఇదే కదా? Yes. Nothing ra, even by looking at the hysteresis curve of the strong and weak magnet, looking by the hysteresis curve of the strong and weak magnet, you can simply say, if this is the graph, ide kada, and for your weak magnet the graph will be a little thinner ra. Ade, there is the only thing that you have to understand. ఇదే కదా? Yes. So the graph looks something like this. That's it. Okay, there might be, I'm not a good sketch artist, okay? So try to understand. Anyhow, it's not working fine. Ade. So that is it. Andariki. What do you say? The strong magnets have the large area. Andariki idigo. Large area ante entira? This area kada? Yes. And the weak magnets have a low area లేదా small area. అదే, what does this area represent, sir? The area of the hysteresis loop, it simply represents, ఇదిగో, the area of your hysteresis loop represents, అందరికి చెప్పండి, represents the energy loss, okay, the energy loss per cycle లేదా per unit cycle, okay, frequency, ఒక frequencyలో how much energy has been lost and per unit volume. Finished. Okay, so here your entire chapter of your magnetic properties and magnetism is completed. ఇప్పుడు చెప్పండి వాట్ ఎవర్ డౌట్స్ యూ హ్యావ్, లేదంటే వీ కెన్ వైండ్ అప్ ద సెషన్ అందరికి. ఓకే, యా కంప్లీటెడ్ డన్. దెర్ ఆర్ సమ్ PYQs బట్ ఐ వాంట్ యూ టు అటెంప్ట్. ఓకే, చాలా ఈజీ PYQs ఉన్నాయిరా. ఓకే, ఇట్స్ యువర్ రెస్పాన్సిబిలిటీ ఫర్ దిస్ చాప్టర్ టు అటెంప్ట్ ద PYQs అందరికి. హాయ్ హలో. సరే, సో అందరికి if you do not have any doubts we can wind up the session కదా. Yes, సరే. So this was all about your magnetic properties and magnetic సరే. Let me see the chats. Okay. Hi Vaishu, hi. Graph is the same, okay? Graph is the same. Okay, so you're talking about electrostatics analogy kada? Yes, analogy. Same thing, ra. Your magnetic dipole, your electric dipole, same things. What is the difference between your electric dipole and magnetic dipole? Almost no difference. Ide kada? Yes. Idigo. There are some formulas actually I have given you. I want all of you to remember those formulas. Andariki, okay? Sare. Any doubts on here? Okay. Isha, you did not understand the graph, right? So, okay, do one thing, okay? Do one thing. You just go and watch the video in the rewind section once again. If you did not understand there also, you have some 5-7 minutes of time till I explain these formulas. And then if you still don't understand, I will tell you all these things, okay? Choose code. The basic difference, okay? The basic difference between your magnetic dipole and your electric dipole is nothing much. Our case low, you only have your P bar and here you have your M bar. Remaining migita, everything is the same. Andariki choose code. So when you talk about your differences and entira, this is your magnetic moment B bar, leda magnetic field, and this is your electric field E bar. When I'm saying magnetic field, I'm talking about magnetic dipole. When I say your electric field, I'm talking about electric dipole. Yes. Now, it is understandable for everybody to understand the differences. There are no differences actually, okay? There are a chala similarities unnai. So the first similarity that you would be talking about is the magnetic moment M bar. What is the value, sir? It is equals to simply M into 12. Ide kada? Yes. Here also you have your electric dipole. Electric dipole ra. Cheppandi. What is the formula for electric dipole, sir? The second thing is P bar kada? Yes. So P bar is equals to the charge into the distance 2L bar. Ade kada? Yes. Point number 2. Cheppandi. There are some 3-4 topics, I think so. The next topic is the torque ra. Torque kada? Yes. Torque on magnetic dipole. Here you have, hey, it should be number one, okay, number one. Your torque on electric dipole kada, yes, ee case lo you will simply say torque of your electric dipole p bar. Cheppandi, it is simply equals to p bar cross e bar ra. Now how did this come, sir, and all these things I have explained in your electrostatics chapter, okay? We are not wasting our time. Torque on m bar kuda we have seen in your magnetic moment, magnetism chapter, m bar cross b bar, ide kada, yes. Next thing cheppandi, your energy to rotate, అదే లేదా you will simply say you energy కదా, yes, energy of dipole రా అందరికి చెప్పండి. Energy of dipole అంటే magnetic dipole m bar. Energy of magnetic dipole m bar is m bar dot b bar. Here also your energy of electric dipole e bar is simply equals to p bar dot e bar. You are understanding when I say energy ra ante potential energy, you are understanding it should be negative sign. Idigo అదే same thing. That means energy and entira, if this is your magnetic dipole, this is your electric dipole, they have similarities kada, yes. And if they are placed, it's an electric dipole andariki, and it is placed in the external electric field. Ide now magnetic dipole placed in the external magnetic field. Okay, now what you're doing, you have to rotate this by an angle of theta. Ide kada, yes, theta 1 nunchi theta 2 values. I have to rotate it from theta 1 to theta 2. What to do, sir? Nothing. Do nothing. Ade you'll simply say your work done ra idigo andariki. Ide kada, yes. So your work done in a rotating is simply equals to m bar dot b bar kada, yes. Ante your potential energy idigo, it is your potential energy, that's it. Ante the change in energy will be gone in work done ra. If it is potential energy, you will simply say, sir, potential energy final minus the potential energy initial. Ade kada, ante mb into cos of theta 2 minus of cos of theta 1. Here also the same thing. Fourth thing, ante the work done in a rotating, ide kada, yes, work done in a rotating is equals to cheppandi potential energy final minus potential energy initial ra, ante uf minus ui, that is simply equals to pe times of cos of theta 2 minus theta 1. Ide kada, yes. What next is remaining andariki cheppandi, I am looking at you only. Now there are some things, okay, there are some things cheppandi. Fifth one, I'm directly writing, okay, field formula cheppandi ra okasari. So if this is your electric dipole andariki chuskondi, this is your minus q charge, ide me plus q charge kada, yes. So if this is your electric dipole and you want the electric field at a general point that is making an angle of theta, cheppandi, what is the electric field, sir? It is simply equals to kp upon r cube into root of 1 plus 3 times of cos square theta. Ade same thing. ఈ కేసులో కూడా in your fifth point you have the same thing అందరికి. So if this is your south pole, ఇదే మీ north pole ఉంటే you understand అందరికి. What you do, you replace this value of k, okay, replace this value of k with mu naught upon 4 pi. Gone, everything gone. Cheppandi. So here also if you want the magnetic field, okay, your magnetic field ra, so your value magnetic field b bar is equals to చెప్పండి k వాల్యూ అంటే mu naught upon 4 pi r cube into, instead of this p అంటే ఎలక్ట్రిక్ డైపోల్ కదా, రీప్లేస్ ఇట్ విత్ m. అదే సో mu naught m upon 4 pi r cube into root of 1 plus 3 cos square theta. ఇదిగో you are understanding. అదే now you can talk about the axis point and the equatorial point. So these are the general points, okay. So this is for the general point. Substitute the value of theta as 0, మీకు యాక్సిస్ పాయింట్ వస్తుంది. సబ్స్టిట్యూట్ ద వాల్యూ ఆఫ్ థీటా యాజ్ 90 degree, మీకు ఈక్వటోరియల్ పాయింట్ వస్తుంది. అదే కదా, ఎస్. సో ఎలక్ట్రిక్ ఫోల్డ్ హ్యాస్ బీన్ కంప్లీటెడ్. నౌ టెల్ మీ వాట్ ఎల్స్ ఇస్ రిమైనింగ్. ఓకే సరే, your doubt has been completed. Isha, did you understand? Sir, I think everything has been clear. So let us wind this session up. Andariki, okay? Chalo, good. Bye bye. Bye bye, everybody. Good night. Right, your chapter and your entire syllabus has been completed. Okay, I'm declaring here officially. Yeah, for sure there are some things into your vernier calipers, your screw gauge and instruments and all that. Kani, I'm not taking them now. I will take them exactly before your examination. Okay, ante 1 week before your exam, NEET examination. Okay, I will take them. Endukante if I take now, you'll forget it anyhow. Okay, sorry. So ippadi kosam your syllabus has been completed. Now, whatever topic we'll be taking next we'll directly jumping to your PYQs. Until tomorrow is a holiday, until Sunday kada, yes. So I think yeah, whenever the classes are starting, we'll directly start with the PYQs, and that too we will take chapter wise PYQ, or we will take the merged and a clubbed PYQ. I'm not having the idea about it. Andariki. So you tell me if to take the chapter wise PYQ or to take the merged PYQ. So we will go in the same way. Okay, sorry. I think it would be better if we go chapter wise. Okay. Anyways, and one more thing, Andariki, when I'm solving the PYQ questions, you just look at the speed. Point number 1, the speed, formula application, at the same time the simplification strategy. Okay, because you want to save the maximum time in your examination. Anyways, right. Okay. Good night, everybody. Bye. Bye, everyone. Bye. Bye.